2.5, absolute value. Now this is equations though, so we're going back to equations. The good news is that it's still an equation, okay? It's just, there are some minor differences. When we see absolute values, one of the main things I want to say is that you should never distribute. As much as you may be tempted to, don't distribute when you see absolute values, okay? So absolute values, what are absolute values? Absolute values is always asking how far away a distance is from zero, okay? So what you see right here, if you're to look at this one right here, that, by the way, that absolute value symbols are just kind of two lines like this right here. And then usually there's a number in between, like we see right here, okay? Now, what is this saying to us, okay? Well, that would say, now it reads the absolute value of -5, right? We want to be technical there. That's what that first one reads. What is it asking, though? It's asking how far is -5 from 0. That's what it's asking, right? And that's why you see that it equals, and it actually equals 5 right there, okay? So some students get caught up with this as though it were opposites, okay? But look here. This one is saying the absolute value of 5, which is asking how far is 5 from 0. But see how it's still 5 right there? It has nothing to do with opposites. It's always going to be positives because absolute values are always positive. That's because it's a distance. And if you can think of this absolute value stuff as a distance, you'll know that you can never get negatives out of an absolute value, okay? It'd be like saying, like if you talk about distances, hey, I live -40 miles south of here. You know, you may confuse some people. They may look at you a little weird. Maybe they don't want to be your friends anymore, and you can have a good career in politics someday, tricking people, okay? But for now, that is a distance, and we don't ever refer to distances as negatives, okay? So we're always going to keep these as positives, all right? How far is it? Again, that's a distance right there. Yeah, what you can ask what values of x would make that statement true. That's going to be important because we're going to start out with numbers in the absolute values, but eventually we're going to see variables in there. We got to solve those like we would equations, but with a slight catch. Right? Absolute value 43, again, this would be like asking how far is 43 from 0. That's the question it's really asking, and well, that would be 43. It's 43 units from 0. Again, it's a positive, always positive with absolute values. So see this one. This is asking how far is -1,524 from 0. Well, as it turns out, it's 1,524, I'll say units from 0. Okay? And again, this one is an opposite. It's just that absolute values are not opposites. It's always positive is what it comes out to. Now you're going to see this one and you may think, well, you just lied to us, Sal, that it's always positive because this one is an order of operations problem. That is why this is going to come out as negative. It's not that it's coming out of the absolute value as negative. So you take the absolute value here. If this was order of operations, which it is, you'd ignore this negative on the outside. You'd do the parentheses first, and absolute values classify as parentheses. So you got to do those first. How far away is -2,635 from 0? 2,635. That's how far away it is from 0. But see, now I take this negative on the outside, and I have to apply it to that, okay? Some students, and so the answer, by the way, is -2,635. But some students like to see this not just as a negative, but as a -1, and it's being multiplied by the absolute value. If that helps you out, then do it. It's -1 times whatever you get out of that absolute value. All right, so principles of equality. These will still apply for, well, these are equalities. It's just that with absolute values, now we're not looking to isolate just the x. We have to isolate the absolute value itself, like we were manipulating an equation. I think that was 110 in Module 1 that we went over, okay? We have to manipulate or solve the equation for the absolute value, okay? But again, it's just principles of equality. Whatever you do to one side, you got to do the other side. Sometimes you use division, multiplication, subtraction, addition. Doesn't matter. Whatever you do to one side, you got to do the other side, okay? So, well, this process is still the same, and you could put absolute values. You know what? We're not isolating the variable right now. We're isolating the absolute value, and then it's just not as quick as dividing by the coefficient. there's a little bit more after this that has to happen. And again, we're not dealing with inequalities here, so that last statement's not really applicable. All right, absolute value equation. So for an equation, this is the absolute value of some number equals, that'd be a number right there, by the way. So you could say, let's just substitute a value in there to give it some meaning. So the absolute value of x is 10, right? In fact, I'll write this separately. Absolute value of x is 10. So see how now there's a letter inside the absolute value? And you have to think about this because this is new. But the question that this is now asking is what value, and I'm going to purposely put this, or values, are 10 away from 0? And some of you, of course, would say, well, 10, of course, is 10 away from 0. But it's not just 10 that's 10 away from 0, 10 units. Negative 10 is as well, okay? So this means that you're going to end up with sometimes two answers for these types of problems that would then have, it would make this original statement a true statement, okay? Let's see, if A is positive, then solve, yeah, that's true. If A is 0, you only get one answer. But if A is negative, then it has no solution. So let's go through these, okay? If you have the absolute value of some number equals 0, well, what number or numbers are 0 away from 0? Only x equals 0 is. That's the only one that will make that work. It's just a unique scenario. I don't think we're going to see that too often. But what if it was a negative? Well, the absolute value of some number is, let's say, negative 5, okay? So what value is negative 5 away from 0? Again, this is a distance thing, right? So we never talk about distances in terms of negatives. So this one we would say, I think on the homework it ends up being a D and E. It can't happen. There's no solutions to this one, okay? So what about the absolute value of x equals negative a? Again, this would be one of these, if that's a negative value, then you end up with it just doesn't exist. No solutions on that, okay? Now, the situation that we're going to see most often is this one, okay, where you end up with two solutions like we saw right here. And I like to show it a very specific way, although you don't have to. If by chance you get an absolute value equals an absolute value, you just say, look at the first one, and then you say, well, it can equal the other absolute value, but not only it's positive, but it's negative as well. And I think we'll see an example like that too, okay? Again, that's not a very common scenario, but you will see that on the homework. And then this one is again, it's not as common as the first one, but we see it from time to time. Sometimes we don't even see this one right here, okay? This is our first example. Absolute value of x equals 7. So once again, what is this asking? What value or values, you can say numbers if you'd like, are 7 away from 0 is, or are 7 away from 0? Well, once again, you could say x equals 7. That's pretty good. But also x would be negative 7 too. If you replace this x with either one of these two values, you're going to get a true statement, right? And you could try this out just to check. Absolute value of x equals 7. Well, I'll replace the x with 7 and see what I get. So there's a 7 right there. Yeah, 7 is 7 away from 0, so that's 7 equals 7. That's true. Well, what if I made that 7 a negative 7 right there inside the absolute value? Yeah, it's still 7 away from 0 here. So that would still give us this 7 right there, which is still true. See that? And so the way that I like to see these, the way that I like to do them, not that you have to, but I like to show that this, from the inside of that absolute value, I'm going to split it up into two parts. One would be the positive of this number, and then the other one would be the negative. But by doing this, this is only, what I'm showing here will end up being on the inside of that absolute value, but it will force the statement to be true, okay? Something else you need to notice about this example is that we only do this part once we get the absolute value isolated. Okay, so if there was anything multiplied out here or added to this absolute value, I'd have to zero those out or make them phantom ones with principles of equality before I can split this up. Okay, otherwise it's going to jack things up real bad. Yeah, so you hear this one? So I got stuff on the outside of the absolute value I need to get rid of. And we'll figure out what the solutions are. But I got to use some principles of equality to isolate my absolute values. Right now I got two of them, by the way, and I don't even want two of them, but I don't want that plus 256 first. So subtract 256 first from both sides. Okay, that zeroes that out just like I want. Now I get two absolute values of x's equals, 8 and a 1, 6, 5, 3. There we go. 368. Hopefully I did that right.
Yeah.
Oh, thank you. All right. Well, now, so that was one principle of equality, just to isolate my absolute value. Now I'll divide both sides by 2 to make it just the absolute value of x, which now equals, it looks like 184. Okay.
Yep.
Now, as awesome as that feels, like, holy crap, we just did a lot of work right there and it feels good, we're not done. We got to split this up, right? Now again, these two arrows, these two lines coming out of the absolute value, that represents the inside of the absolute value. Meaning, if I could get x to be 184, I'd get a true statement right there, okay? But if I could get x to equal the negative 184, that would be true as well. And again, this negative part right here, the positive I hope is kind of obvious. Or if it's not right now, hopefully it will someday. But the negative, this one is where we get some problems. It's like, well, if I put a negative 184 in there, does it make it a true statement? Yes, it does. Yeah. Replace your x with negative 184, you'll get a positive 184 because it's 184 units away from 0, okay? Now, if by chance, and this is more hypotheticals because we're going to see them, but if, let's say you had like x plus 2, then you would have written x plus 2 here and x plus 2 there, and then you'd have to use more principles of equality to solve. But for now, it's just x, which is just a nice starter problem for us, a nice little introduction, give us a little foothold to launch off of, okay? But that right there, since there was nothing else to do after we split these up, we'll just write it as one equality. X equals 184, comma, and I think on some of the problems on the homework, they want you to use that comma right there. I just don't think that they care if it's small and then big, or big then small like I have. It doesn't matter. As long as you get the two right answers, it should be good. Before you ever do any splitting like I did right here, you have to isolate those absolute values like that. So here we go. Here's another absolute value problem. Again, there's nothing on the outside being added, subtracted, multiplied, or divided by this absolute value. So I'm free now to split this up into two separate equalities, right? So that means if I could get x minus 9, if I could just get it to equal 2, right? If I could make this 2 right there, I'd get a true statement, okay? So that's what that means. But if I could get that x minus 9 on the inside, if I could get it to equal negative 2, meaning if I just had a negative 2 right there, that would also be a true statement, okay? So again, that's why we split this up into two parts. Two different equations right now. All right, now both of these, by the way, are one-steppers. I think that makes that very nice. So this one on the left, right? I have to isolate the x, just add 9 to both sides. And yeah, it's already an x, so that's nice. This zeroes out. X equals, looks like 11 there. And then on the right, same thing though, you'll see, got to add 9 to both sides. So some students choose to do this at the same time because it's the same principle of equality that you're applying to both problems, right? So, I mean, it's not always this symmetric, but that's going to zero that out. X now equals negative 2 plus 9 is positive 7 right there. So that finishes this problem. X is just equal to not just 7, but also 11. 7, 11. Oh, that's pretty good. Now you could check, right? You could say, well, look, what if I put let's say 7 right there, okay? Well, when you combine these two, you're going to get that negative 2, which is, that's where this negative 2 comes in, right? This negative 2 was on the inside of the absolute value, and this is just checking. But what's the absolute value of negative 2? It is 2. That checks off, okay? Okay, well, what if we make it not 7, but let's make it 11, right? Well, 11 minus 9 is 2. Now that green 2 in positive right there, that's this 2 right here, which was positive. It's not this one yet. It's not this one until it's evaluated completely. The absolute value of 2 is 2. Now it is. Now it works. All right, let's solve this one. You know what? You guys solve it. See how you do, okay? 1 minute. So same thing on this one. I'm going to split this up into two separate equations, but without the absolute value, right? Because I can say, well, 4x plus 2, if I could make it be 6, that would give us a true statement. But if I get 4x plus 2 to equal negative 6, that also would be a true statement. And again, the 6's we're seeing here are not yet the 6. These 6's would be on the inside of the absolute value first. So, but now I am ready to solve these. So, yeah, just like I was saying, some students like to do it like this. It's like, well, I know I'm going to have to subtract 2 from both sides here, but also subtract 2 from both sides here. If you want to do them simultaneously, you can. And if that's convenient for you, do it, okay? But now I'd have a 4x here on the left equals 6 minus 2 is 4. And on the right, drop my 4x. Negative 6 minus 2 is negative 8. Well, that's going to be convenient. Because now when I divide both sides of both equations by 4, I get x equals 1 and also x equals negative 2. Okay, so if we go back, if I were to replace x with 1, I'd get a true statement. We can check that. 4 times 1 is 4, plus 2 is 6. That's positive. How far away is 6 from 0? 6, so that's true. How about negative 2? Would this work? Let's find out. 4 times negative 2 is negative 8. Then adding 2 would make that negative 6. How far away is negative 6 from 0? It's 6, so that checks off as well. And looks like we found 2 good answers for this one.
The 2 on 1 switch.
Oh, that's fine.
Because you did that for the 7 level
Yeah.
one.
Yeah, you can if you want. Any other questions here on this one?
7-Eleven.
So on this one, I'm going to split this up once again into 2 separate equalities, because these are equalities. We will deal with inequality absolute values, but not yet. So if I can make x plus 12 over 3 equal 1, that'd give me a true statement. But if I can get the inside x plus 12 all over 3 equal to negative 1, that'd give us a true statement too, okay? I'll do these one at a time, although you could do them simultaneously. I'll start with one on the left here. Now for me, I want to get rid of that divide by 3. That means I need to multiply both sides by 3, making that a phantom 1. And it's not just crossing those out. That is a 1. It's just slanted. And then x plus 12 equals 3. Well, now just subtract 12 from both sides. And we see that x would need to equal, looks like negative 9 right there. So that means, so let's go back and check just this one answer. If I replace x with negative 9, negative 9 plus 12 is 3, divided by 3 is 1. That's the red one right there. And the 3 is this 3 right there, but the absolute value 1 is 1, so that's true. Okay, well that one was nice. But now the next one, same process, multiply rather, both sides by 3, make that a phantom 1. Now x plus 12 equals negative 3. And then subtract 12 from both sides, same thing. Different answer though, because it was a negative to begin with. I get x equals negative 15 right here, okay? So let's go back and check this one. Negative 15 plus 12 is negative 3, so there's that one. Negative 3 divided by 3 is negative 1, there's that. The absolute value of negative 1 is 1, that's true. So we see now that x would not just equal negative 9, it would also equal negative 15 as well, both making the original equation a true statement. Now, the reason why I'm showing this one is because some students look at this problem, they're like, oh, it equals a negative. You told us if it equals a negative, it's not true. No, you got to get rid of everything on the outside of the absolute value first, okay? So we need to isolate that absolute value. So for me, first off, I subtract 6 from both sides. And yeah, that'll drop by negative 4 times the absolute value of x equals, yeah, this is going to zero out, but negative 6 minus 6 would be negative 12. And see, now when I divide both sides by negative 4 here, it's going to give me the absolute value of x equals positive 3. And that's okay. We can do that one, right? But now that we've done that, I'm ready to split it up in 2 separate equalities. If I could get the inside x to equal positive 3, it would be a true statement. But if I get the inside x to equal the negative 3, it would still be a true statement. So nothing else to do there. Like I said, sometimes you'd see what we've seen before, like 2x plus 5, you'd have to solve from there. But that's as far as we need to go on this one. If I made x 3, it'd be true. If I made it negative 3, it'd be true. And again, you can check. Absolute value of 3 is 3. Negative 4 times 3 is negative 12 plus 6. is negative 6, so that's true. Negative 3, absolute value of negative 3 is 3 times negative 4 is negative 12 plus 6, negative 6, still true. Now let's give this one a shot too. And again, this is one of those where it's like, hey, it equals a negative. Can't have that. No, gotta get rid of everything on the side there. So I don't want that negative 35 with that negative absolute value of x. So I'm gonna have to add 35 to both sides. Okay, plus 35 to both sides. That's nice. Gonna zero that out. Negative 27 plus 35 is 8, and that's positive 8. So now the negative absolute value of x equals 8. Now some of you, like I said, may benefit from seeing that as negative 1. And if that's you, feel free to do that, okay? It's not a big deal. But what we don't want to do at this point is distribute. Never distribute with absolute values. It's not that you can't, it's just that some special scenarios are going to change things up. Like this one. Let's divide both sides by negative 1 to make that a phantom positive 1. And we get an absolute value of x equals now negative 8. Now, if you continue kind of mindlessly on this one, because we are getting used to it, which is, I mean, it's understandable. Some students say, hey, look, x equals negative 8 and x equals 8. Hey, that's pretty good, right? The problem with this is that you can't have an absolute value come out as a negative. Remember, this is a distance problem, and you got a negative value for that. That's no good. So all this was irrelevant other than to show you common errors that we see. At this point, we would just say that it's a D&E kind of problem right there. All right, so once again, we see this. We have to isolate the absolute value, not the x's, the absolute values, right? Now, another common mistake we see on this one is this. And pretty much if I see this on the exam, because in the past exams, they've had problems like this one on it, okay? But if I see this on the exam, you get negative 5, I pretty much have to take all the points away. Because it's out of order, right?
Yeah.
You can't combine those two. They're not even like terms, and you may just be missing that there is a multiplication between the two and the absolute value right there. Again, I would avoid this. I mean, you could technically do it in this problem, but I would avoid it. Okay, we don't want to see distribution into absolute values, so don't do that either, please. But what we do want right now is to isolate that absolute value, so I want to get rid of that negative 7 by adding 7 to both sides. So that zeroes that out. Still got that to positive 2 times the absolute value. What do we get? 19 plus 7 is 26 there. And now I will divide both sides by 2. So this goes back to that little trick we saw where instead of distributing, like this one, we shouldn't distribute, I should say. So to get rid of this 2 times the absolute value, just divide both sides by 2, okay? And that makes that a phantom 1. So I'm now left with the absolute value of 5x minus 3 equals 26 divided by 2, 13. Yeah, I think that makes it a little bit easier. I hope it does. And now I'm going to split this up, okay? So if I could make 5x minus 3, if I could just make it equal 13, that would be true. But if I could make 5x minus 3, if I could just make it negative 13 as well, that would still be true. It'll still give us a true statement right there. All right, so let's do, I'll do the one on the left here first. So, add 3 to both sides. So that's going to zero that out. So 16, 5x equals 16. Sorry, that's kind of small here at the end. But then divide both sides by 5. Now, there's a fraction, and that's okay. X can equal a fraction, 16/5. Looks like. And then the one on the right, same thing. Add 3 to both sides, just like we did before, but yeah, it's going to change it a little bit. Now my 5x equals negative 10. Then divide both sides by 5 makes x equal negative 2 right there, okay? And again, even though we got a fraction, even though we got a decimal, that's not a problem. We see now that x could equal 16/5, but also negative 2. That's good. On a problem like this one, I like this type of problem, okay? Now, here's what you should not do on this problem, is work on the inside of the absolute values, because we don't know what's gonna happen on the outside, okay? Let's do that first, and once again, please do not do this. In the past, when I see this on a test, it's an automatic minus usually 8 points on the exam, and then I just have to feel bad about it because maybe the rest of the stuff looked good, but you can't start out wrong like this, okay? So do not combine those two terms. They're not even like terms. But what we should do is isolate the absolute value. So I'm going to, subtract 19 from both sides. So what does this give me? That zeroes that out. And we get all this stuff here. Thank goodness for technology, because I don't want to really write all that stuff. But now this equals negative 26 right there, okay? Now when I divide both sides by 13, what does this give me? It gives me this absolute value, because that becomes a phantom 1 right there, equals, looks like negative 2. See, and this is the point here, okay? Is some of you, if you had started this problem, you'd say, oh, I got to distribute, then I got to combine like terms, and then that simplifies it. That's great. But here, see, this is a negative 2 right there. This is a D and E problem. It just can't do that. Can't have a distance that's negative for us, okay? So I kind of like that problem because as complicated as it looked, as big as it was done pretty quick. So, yeah, I mean, yes, you're getting a little bit ahead there, but I'm still going to do it, okay? This one, I hope it doesn't take as long as you think. Now, we did talk about this. Remember, you're going to split the first one up. You could split up the second one. By habit, I only split up the first one, okay? So here's what happens. I'm going to take what's inside that absolute value, so that's a negative 4x plus 5, and I'm going to make it equal the other inside of the absolute value too, okay? So that's 3x plus 5 right there, okay? Now that becomes one of the equations I have to solve. The other one takes pretty much the same exact statement here, but remember, you have one that's positive. This is positive, and then the other one would be negative here. So I'm going to make this, I'll put the negative sign like this, okay? Some students like to show it with just 4x plus 5, that's good. But then they know just to change the signs, so that'd be, after you distribute that negative 1 right there, you're going to end up with negative 3x minus 5. Like I said, some students prefer to think of that as just changing the signs of every term on the right side of that absolute value of the equation, and then solving from there, okay? So, it does kind of change things up for us, but yeah, look, we got absolute value. I'm going to put the x's on the right, make them positive. Not that it matters, but that means I have to add 4x to both sides. And then subtract 5. Oh, that's nice, actually. That zeroes that out. This one, now it zeroes this one out too, but I need to show that 0. 3x's plus 4x's is 7x's. Divide both sides by 7. Yeah, x is still 0 here. So x being 0, looks like that would give us a true statement. You could check. 0 plus 5 is 0. 0 plus 5 is 0. 0, absolute value is 0, 0. So that's good. And then the second one, same thing, well, slightly different, because I will put the x's on the right, looks like. And numbers here, so add 4 x's to both sides, making that just an x, which is nice. But then adding 5 to both sides. So that looks like 10. So it looks like 10 would work. Negative 40 plus 5 would be negative 35. And then 30 plus 5 would be 35. Now they're opposites, but after you take the absolute values of those, they're going to be positive. And so that checks out. We end up with these two answers. X is 10, but x could also equal 0.